Okay, here's a pulley problem. And we've got this mass here, the mass B, which is 5.63 kilograms, right? And then we've got mass A, which is 23.1 kilograms, right? Now there's no friction between A and the table, and this pulley is frictionless. So then the question is, does it even turn, right? That's always the question, right? Let's not worry about that. The first thing what we want to do is we want to set up the draw a picture of all the forces, right? Now as this thing slides this way, the only force acting on it is of course the tension in that string, right? That tension in the string is also pulling up on B, right? So it's the same force, and that's because this string is massless and that pulley is frictionless, right? Otherwise it's, I guess a little bit more tension here because of the weight of the string or something like that. And then the next thing to do is to figure out, of course, the force of gravity on this guy, right? So, and I'm going to predict that this thing accelerates this way because why wouldn't it accelerate that way, right? Okay, so the force of gravity right there is just going to be m times g, so 5.63 times 9.81. Let's do that. 5.63 times 9.81. I'm going to store that in A just for fun. 55.2303. Right? So that is this force here. Okay? So the first thing to do is to draw a picture of all the forces. There is no force this way on A because there's no friction, right? There's only the tension on A, right? And then on B, you've got the tension is up and the 55.2303 is down, okay? The next thing you do is you decide which way acceleration is, right? So acceleration is to the right on this guy and acceleration is down. That makes actually the down direction positive for this thing, right? I always make the direction that A is positive, right? I make everything positive in that direction. So this force is positive, tension is negative for this one, right? So the expression for B, the Newton's second law for B, looks like this. We've got 55.2303, and I'm just setting up F equals ma, right? Okay, minus the tension equals 5.63 A, and we have two unknowns. We don't know the tension, we don't know the acceleration, right? And this is for mass B, right? Okay. For mass A, our formula it's just simply this: T equals 23.1 A, right? That's for mass A. Now, because of the way strings work, because if it's accelerating, right, the string is pulling one mass one way, the other mass the other way, right? It always is the case that we can solve these by simple linear combination. We can just simply add the equations. Okay, with massless, frictionless pulleys, these are always deadly simple. So if I add the left side and the right side together, I get, well, 55.23 minus T plus T, right, which is just simply 55.2303, right? And then that equals 5.63 plus 23.1 A, right? So that is, of course, 28.73, right? 55.2303. I'm just suspicious of myself enough that I'm going to add that with a calculator. Yeah, hey, I got that one right. Okay. And now we can just simply divide 55.2303 divided by 28.73. And I get 1.92239. Meters per second squared, right? Okay, now that's only part of it. Now we have to figure out what the tension is, right? So now I'm going to plug back in here, okay? Now I'm going to plug back in here. Let's just plug this value in, right? Okay, so T equals, look at that new color, 23.1 times 1.92239. Right? I just picked the simplest equation to plug back in. I plug this guy in for A, right? Okay, so times 23.1, and I get the tension is 44.407. Ta-da! Okay, so there's our answer for that. There's our answer for that. So our steps, the steps are, the first step is to calculate all the forces that might be acting. In this case, we had to calculate the gravity, right? Okay. Then the next thing is to draw all the forces. So tension is pulling this guy to the right, tension is pulling that one up, gravity is pulling this one down. The next step is to decide which way acceleration is. Okay, it's going to accelerate this way. This one was obvious. Of course it's going to accelerate that way. There will be some in the future where we might guess wrong. If we guess wrong, our acceleration will end up being negative. Okay. Doing that, making the acceleration positive, you always go protagonist minus antagonist, right? So this guy is causing the acceleration minus preventing is ma, right? Ultimately, you always end up with the sort of the net force equaling the sum of the mass times acceleration in all these problems. Okay? Good luck and happy hunting.